Our next topic would be high availability and scalability in the cloud. So in this module, we'll complete the following exercise, which is on high availability and scalability in a private cloud environment. And after this module, we should be able to define and describe the importance of high availability and scalability in a cloud environment, compare different options to ensure high availability and methods of scaling a cloud infrastructure, and investigate and analyze scalability options in a private cloud environment. Right, so for our first exercise, high availability and scalability in a private cloud environment. Now, the concepts refer to always ensuring that your infrastructure can satisfy the demand and utilization needed by end users. This is a key focus area when planning an infrastructure, as not performing this thoroughly can result in full denial of service to end users. High availability is a prime motive to migrate a cloud infrastructure and ensures redundancy, constant monitoring, and failovers are in place to prevent denial of service. Public clouds also implement availability zones that are isolated, fault tolerant, and highly unlikely to fail simultaneously, and can be a great tool when ensuring high availability. Now, effectively scaling an infrastructure in a cloud environment comes in different forms and ultimately depends on the specific scenario of what needs to be scaled and will vary depending on the circumstances, these options for scaling. And this includes auto scaling. This involves adding resources to maintain on demand availability, typically employed in a public cloud environment. Horizontal scaling, this involves splitting a workload to multiple host machines to make for parallel processing. Vertical scaling, this involves changing resources to handle appropriate performance demands, such as purchasing more hardware to implement in a private environment or incorporating more resources in a public environment. And lastly, cloud bursting. This involves overflowing traffic directed to a cloud infrastructure when existing infrastructure and resources hit 100% utilization, bursting your own infrastructure and flowing it to a second cloud infrastructure. Now, it is key to consider different applications, virtual machines, containers, packages of software code and configurations in a single location, clusters, a collection of virtual machine nodes connected via a virtual private cloud, and other types of resources when considering which scaling options fit them best. Typically, it is recommended that these are configured to be auto-scaling, scaling when they need to. To ensure the HA may require spreading applications over different AZs, VMs have been configured to allow failovers, and containers are hosted inside a swarm. Now, high availability and scalability in the cloud. When it comes to hypervisors, it's a program that partitions different systems resources of a real device to create a virtual device. The ability to spin up different VMs is key for scalability in a cloud environment, as devices can always be created, edited, and removed on the fly, and do not require massive hardware investments outside of the initial server in private cloud environments, and this allows you to effectively scale resources as needed. For examples, when it comes to VMware, Microsoft Hyper-V, or Oracle VM VirtualBox. When utilizing a hypervisor, two methods of networking VMs into an infrastructure exist. The affinity models applies when multiple VMs run on the same host, and the anti-affinity model applies when each VM is run on a different host. Which option is best will apply to the demand on the host. A physical server is limited by its hardware and processing power, and this will vary depending on the infrastructure an organization is looking to create. Now, single points of failure. This refers to a weakness in an infrastructure that points to a specific piece of hardware or resource that could act as the weakest link in the chain, and that, if it fails, the whole infrastructure fails. These are implemented due to a flaw in overall architecture design or not accurately planning for proper scaling options. Allowing SPOFs to exist in a cloud environment is the opposite of ensuring high availability, and therefore should always be considered and reviewed during the life cycle of any one piece of an infrastructure. Now, in a cloud environment, some examples include hypervisors using the affinity model without proper disaster recovery or failover planning. Number two is a hardware security module failure or security vulnerability that could, in effect, remove access to other parts of an infrastructure. And lastly, infrastructure critical software that reaches end of life and no longer being supported by a vendor, potentially becoming unsupported in the future or becoming vulnerable to newly discovered security flaws. Now, this is just three examples, although there are many others that should be carefully considered when planning, and an infrastructure should always be scrutinized to avoid at all cost. Now, oversubscription is a challenge of public cloud subscriptions in that a CSP can oversubscribe a specific piece of hardware to multiple users or tenants, meaning that the server cannot satisfy every tenant's need at once, leading to a potential denial of service. Now, picture that your organization shares server space with another organization that suddenly massively increases demand on the CSP's server. This can have a negative effect on all resources stored on that server, negatively impacting the performance of your resources. This is why this can be apparent when scaling infrastructure on a public cloud, and you should be vigilant that your infrastructure doesn't fall outside your service level agreement with your provider. Now, it is important to remember that the private clouds, this risk is less of an issue as you either maintain a physical server on premises or rent a server from a provider for your organization's use alone. Now, networking functions should also be considered when ensuring HA in a cloud environment and could act as another SPOF in a private environments. The following different types of networking functions and hardware should be considered to ensure high availability, which is when it comes to switches, routers, load balancers, and firewalls. It's also important to remember that in public cloud environments, networking is instead maintained via the following known as virtual private cloud resources, which are subnets, gateways, route tables, or network interfaces. Now, the benefit to using a public cloud in this instance is that the VPC can be managed via one console instead of having different hardware and software components and need to be managed individually, potentially lowering the risk of SPOFs. Now, in this exercise, we will investigate scaling options for VMs in a private cloud environment using Hyper-V Windows Server 2019. Now, for our first task, private cloud scalability and high availability options. Now, many hypervisors allow both manual and dynamic scaling of virtual machines in a multitude of ways, provided that the host device has the partition capacity to enable these changes. This is invaluable in a private cloud infrastructure and will likely need to be amended to ensure integrity and high availability. Now, in this task, we'll explore scalability controls in Hyper-V. Now, let's connect to our server manager. Now, at the top of the page, navigate to and select Tools, and select Hyper-V Manager. Now this will open the Hyper-V Manager window. Notice a pre-configured device already exists as a part of this infrastructure, named as plabwin 101, which will appear under the virtual machine section. Now under virtual machines, right click this and click on settings. In the real-world scenario, it is likely that multiple VMs may be configured on a single device using affinity model. Now on step 4, this will open the configuration settings for the device. Under Hardware section in the left-hand panel, click on Memory. You will notice that by default this device has been configured with 512 RAM, which can increase to improve the performance of this device. You can increase this directly by specifying a new amount of memory in the RAM text box at the top of the page. For this demonstration, let's just leave it at 512 and tick the Enable Dynamic Memory checkbox. Now in step 5, ticking the Enable Dynamic Memory checkbox will enable the dynamic memory option, meaning that this device will dynamically scale depending on the system resource utilization by the host machine. Now this is a good auto-scaling option to use in anti-affinity models, as the risk of hitting max host capacity is less, being that there is only one device. Using this option, you can either leave the maximum RAM to the default entry, which is 1048 gigabytes, effectively meaning it will scale upwards until it hits the max capacity of the host device, or instead manually specify a maximum upper limit. Now this option can be helpful if you have multiple devices working together on a single machine in an affinity configuration, although this should be carefully planned to avoid the host becoming an SPOF. The maximum amount supported by Hyper-V is up to 1 terabyte. In the maximum RAM text box, let's type the value 2048. Notice you can also specify the weight of priority for this device to have access to memory using memory weight setting. In the memory weight section, click and drag the scale to high and click apply at the foot of the window. In step 6, under the hardware section, in the left hand pane, click processor. Now you can specify the number of virtual processors that the VM has access to. This can be helpful to increase for devices that have higher amount of CPU utilization, and again is limited by the number of processors available on the host machine. For example, if a machine was going to be used for a specifically high CPU intensive task, then it would be prudent to ensure that it has access to more CPU power than other machines. The maximum limit support by Hyper-V is up to 240 vCPUs. In the number virtual processors text box, let's type in 3. In step 7, once you make this change, you will notice that the percentage below change depending on the load. This will apply to the host and other VMs running concurrently. Within 3 vCPUs, notice that the percent of total system resources has increased to 75%. With 4 or more, this would increase to 100% and higher. And let's click apply. Finally, under management section, click checkpoints. Note that this is to ensure high availability and minimal downtime of machines as part of an infrastructure in Hyper-V. It is imperative that checkpoints are created frequently to allow easy recovery and failover if any single device fails. This can be helpful in development environments, as code deployments can sometimes have negative effects on machines and may require frequent rollbacks. Now let's tick the use automatic checkpoints. Now ticking the use automatic checkpoints checkbox will automate the process, creating checkpoints automatically. This can be helpful, although it does remove some direct control if relied on 100% of the time. It's key to ensure that, as well as automatic checkpointing, manual reviews take place and more checkpoints are done as necessary. Now click OK at the foot of the page to close the setting. And lastly, close the Hyper-V Manager and Server Manager window. Now we've completed the high availability and scalability in cloud practice lab.